Hi, this is Ms. Delosier, and these are your notes on altruistic behavior and kin selection. So before we can talk about what kin selection is, we have to talk about what altruism is. So when we're talking about behavior, altruistic behavior is any behavior that reduces an individual animal's fitness but increases the fitness of others in the population. And when we're talking about fitness, you have to remember we're talking about an individual's ability to survive and reproduce. So any behavior that reduces an organism's ability to survive and reproduce, but increases the probability that other individuals in its population will survive and reproduce. We would classify those as altruistic behavior. So we're going to look at an example. We're going to look at the example of some meerkats. So meerkats post one or more sentries outside of their burrow, and those sentries stand guard while the others forage or play, and they will give an alarm. They bark. So anytime anything that's a possible danger to them, a predator, a band of other meerkats come along, they will go ahead and they'll give an alarm, and they have many different types of alarms. And then the sentries will go ahead and wait until all the other meerkats are in the burrow, and then they'll be the first ones out of the burrow, and they will alarm during this whole time. So you can imagine that if I'm standing up and there's a predator there and I'm barking, I'm drawing attention to myself. So that's going to reduce my probability of surviving and thus my probability of reproducing. So that's decreasing my evolutionary fitness, but if it allows the other individuals in my population to survive, then that's increasing their ability to go ahead and survive and reproduce later. So that's increasing the fitness of the other individuals in the population. So we would categorize that as altruistic behavior. Now, altruistic behavior is kind of puzzling. It kind of doesn't make a lot of sense as to how altruistic behavior would actually happen. Because in meerkats, there has to be some genetic underlying for that behavior. So I'm a sentry, I have a genetic underlying to alarm, but it's going to lead to me having a short life expectancy and not living very long and not having very many offspring. So how am I passing that gene for altruistic behavior on? So we have to look at something called the inclusive fitness. So the inclusive fitness is the fitness through producing offspring and providing aid that allows my relatives to spread any shared genes that I have. So if you think about inclusive fitness, not only is my fitness just my ability to survive and reproduce, but it's also the ability of those who I have the same genes as surviving and reproducing. So it's not just about me spreading my genes, it's can my relatives spread those shared genes? And so that's the term inclusive fitness. And so inclusive fitness kind of makes it so altruistic behavior makes a little bit more sense evolutionarily. So that's kind of the ultimate causation of why altruistic behavior exists. It exists because it allows close relatives to spread those same genes, even though I might die by doing the behavior. So we're going to go ahead, and this inclusive fitness was proposed by Hamilton, and so we're going to look at Hamilton's rule. Now, Hamilton's rule is in your textbook. It's in chapter 51, and it looks a little scary at first glance. Hamilton's rule is that R times B must be greater than C. So we need to talk about what those variables are. I'm not going to actually ask you to calculate Hamilton's rule ever, but I want you to kind of understand what it means so you understand the concept of kin selection. So R is the coefficient of relatedness, and that's just, there's a mathematical table that basically says I'm half related to my siblings, I'm less related to my cousins. So there's a coefficient of relatedness. The closer related you are to someone, the higher the number that is. B is the benefit, and that's the benefit to whoever I'm helping. So we quantify that as the average number of extra offspring that the recipient of that altruistic behavior produces. And C is going to be how many fewer offspring the altruist is actually going to have as a result of their behavior. So if I sacrifice myself to go ahead and save a sibling, then not only do I need to know how many fewer offspring I'm going to have as a result of that, that would be C. I need to know how many more offspring they're going to have as a result of it. That would be B. And so basically you just plug those numbers in, and if R times B is greater than C, then natural selection will actually favor altruism, because if mathematically my sibling is having more offspring than I could produce, when you take into account that relatedness factor, if you take into account that the coefficient of relatedness, and that quantity of the benefit times the coefficient of relatedness is greater than the cost, then it makes sense for that gene to survive. If it's less than C, then it's unlikely that that gene is going to survive, and so that altruistic behavior won't be seen in future generations. So no math, just English. This is what kin selection is. Kin selection is that natural selection favors altruistic behavior by increasing the reproductive success of my relatives. That's all it says. So if I do something altruistic and it allows my close relatives to have more reproductive success, thereby spreading their genes, that's kin selection. So kin selection is an evolutionary explanation of altruistic behavior. So I hope that makes sense to you. Again, don't stress over the math on it. I wanted you to see it because I just wanted you to understand that you have to take into account how related you are, and then the benefit to who you're helping and the cost to you before it actually makes sense. So if you have any questions about that, come on in and I can show you a couple actual example problems.